Okay, so today we're looking at data again, obviously, and another way of displaying our data. So if we get a list of continuous numerical data, if you have a look there, so something like that would be if I collected all of our heights in this class. That would be an example of continuous numerical data. You can then do what we call is a histogram. So a histogram does look like a bar chart, but the difference is that you can see there's no gaps between the bars, and a histogram is only done with generally with your continuous numerical data. Okay, so we're going to look a lot at histograms now, and as I said, a lot of our part of further maths is analysing what does the data say. So once we present it or it is presented in a histogram, we then have to comment on it. So if you have a look here, describing the histogram, just written there, they're the things that you're going to have to say. If they say comment on the data or what does this tell you, this is what you do. So you first look at the shape of the histogram and whether it has outliers. So in a minute, I'll show you how we create a histogram on the calculator, but when we do, they are produced and they look like this. So can you see, first of all, we comment on the shape. So can you see how on this first one, you've got tall towers at the start and then it goes down into a small tail, yeah? That's called positive skewed. So when you've got all the data, a lot of the data at the start, categories, and can you see the opposite way is negative skewed. If you have this perfect mirror image one, so we often call that the bell shape, that's called symmetric down there. And sometimes we might have this one, we might say it's bimodal. Bimodal meaning, can you see that there's two dominant categories there? So there's bi meaning two, so there you go. Now you also need to comment, if you have an outlier in a histogram, you'll see it. See down here, there's a little lonely bar by itself. That's an outlier and you do need to comment on that. There was some extreme value on it. Okay, so with a histogram, and we spoke about this the other day, we then will talk about the center. Now with a histogram, often the median is the best one to use because the median is appropriate when the data is skewed. Remember when I talked about the median being a resistance statistic? So it's not affected by that outlier. So what the median tells you, when you go to the median, you have roughly 50% of the data collected above you and below you. So when you see this skewed data, I'm just going to show you on here, you will see, so up in the positive skewed, you'd see the median occur up in here. So you'll see it fall up where the major part of the data is. When you do it in a negative skewed, you'll see the median, so it'll be up there where it is. And then when it's symmetric, you see the median in the middle. Now, if you looked at the mean, so if I went to go look at the mean on a histogram, when you have positive skew, your mean will be larger than your median. So sometimes when you don't know whether this data is skewed or not, you can actually have a quick look at the median and the mean. And if the mean is considerably higher than the median, then you know it's positive skewed. If you have a mean that is lower than the median, you know you have negative skewed. And what is symmetric? Remember we talked about that the other day. They will be the same. Yeah, they'd be roughly the same. So if you see the median and the mean roughly the same, you can say the data is symmetric. And that's a good piece of evidence to say why you're saying the other bit. So even if you think it looks a bit, if you justify your answer with however you say, because the median's higher, it must be negative skewed and so on. Okay, the last bit that you are asked to comment on, or you can comment on, is the spread, and that's down here. And the spread is simply just the range of the data. So you'll just say the highest value minus the lowest. So here on this histogram, I'll just point on the one with the outlier. My maximum value will be this one, whatever it's there, and whatever this one is recorded, that's the minimum. So I'll work out the range. So if you can see, so that's the range, and you can also comment on the IQR. We'll talk a little bit more about that later. And that's the interquartile range. So let's just have a look at this example over here. And it says the histogram opposite shows the distribution of the number of phones per 1,000 people in 85 countries. Okay, so we're going to go through this, and it says describe the shape. So what is that shape? That one is positive skewed. Okay. Is there any outliers? I don't think so. I can't see it. So I say positive skewed with no outliers. You need to say yes or no to outliers to prove that you've had a look at it and you're making a statement about it. Now, it says locate the centre. So we said when you find the centre, you often find the median. Now, remember I said the median is the middle amount of the data. So if you have 85 countries, what's the halfway mark of 85? 42. So if you can often find the median by going 85 plus 1 divided by 2. So we're going to say roughly 43, yeah? So at the 43rd data amount, that's where the median is. Now, can you see along here, we have a frequency count here. So it is in just a frequency. So I want to get up to the 43rd data. Can you see this column is sitting on roughly, I think, 32? Yeah? So I've gone 32. Now, if I have a look at this next column, it's sitting on, I don't know, roughly 18. Yeah, I'm just going to say that. So would the 43rd data value, if you put them all in order, wouldn't it occur in here somewhere? Because I'm crossing 43, aren't I? I would have counted up to 43 somewhere in that category if I could see all the data individually. So this bit here is where the median is. Now, can you see down here, they comment on that. They said the median category is 170 to 340 phones per 1,000. That's how they work that out. We'll do more practice of these, don't stress, but I'm just showing you how they did that. And estimate, the last one, estimate the spread. So I simply went 1,020 minus 0 was my lowest. So that's where they've just commented on the spread. You don't have to write drib drab. You can dot point that. If they said describe that histogram, I could dot point positive skewed no outliers. The median is the 170 to 340 phones per 1,000, and then I said this, it has a spread of 1,020. That's all you have to do, just dot point it. You don't need to write the rubbish. We don't look for it. The teacher, this examiner won't look for it. They're just looking for that, and they're just going to tick, okay? So see how that report blabs on? You don't need to. Okay, the histogram, and I'm looking down here now at the next one. The histogram below shows the distribution of secondary school attendance rates in percentages. So for 200 countries between the year of 2000 and 2007. So the percentages is actually the category. It's got nothing. It's not a percentage histogram. It's actually a count histogram. It's just that the categories have to do with a percentage. So if you look at it, the question, it says the percentage of countries with secondary school attendance rate of 55% or smaller. So if you look here, here's the 55% and smaller, all of those. Now, when they've asked me for a percentage, remember what I said the other day, always go your amount over your total times 100. Now, if you look, the total is the 200 countries. So I said of the countries. And then we want to know how many are 55 and smaller. So I'm roughly going to go, I don't know, that looks like 32 plus this one, which I might say is 18. So I'm up to 50 plus another 20, 70 plus another 15, 85 plus another 9, maybe 94, okay? I'm doing it rough. And then if I have a look at those answers, which one is roughly going to be 94 out of 200? I'd say this one, yeah? D, 54%. If you work that out, yeah. 100 is half of 200, so roughly 200, yeah? Oh, was it 46? Yep, am I bad? It's lower than what I think? Yep, sorry. Oh my God, that's going. So it's not quite half, so about 46%, but you can work it out. And it was around that. Okay, this is an example of an exam question, so I'm just going to go through it with you. So the histogram below shows the distribution of the population size in 48 countries in 2018. So this is question 1, so it should be our really easy and basic question. So the number of these countries with a population between 5 million and 20 million people. So you want to go between 5 million, which looks like here, up to 20 million. So if you have a look, it's saying the number of countries. So if you look at this one looks at like it's 11. And what's the next one is 4. And this one is 2. So 11 plus 4 plus 2 would be 17 countries. So I'm just adding up the totals there. The shape of the histogram is best described. What is this one looking like?
Negatively skewed.
No. This one is positive skewed.
Yeah, it's going from right to left.
Boys, that one's positive skewed, just to reinforce that. So when the data's all up the front at the start, it's positive. Now, out here, this guy's floating out there, so what do we call that? Outlier. Yeah, so the best answer is probably positive skewed with outliers. Okay, so write that one. All right, can you see with this data, a lot of the countries they're all around here, aren't they, in this small zone? Isn't it? And that's because it's going to be most countries are going to fall in between those values, but then we're going to have a couple of these bigger countries. So there's only a few, I don't know, don't quote me on it, I don't know what the big countries are, Russia, America, whatever. So what happens is we like to change these histograms and we like to put a log scale on it, and that's what we're leading into now. So I'm going to go to the next page, and we're going to look at a log scale. Now, what a log scale does is it tells you we change the number to be like in index form. So if you have a look, I'll just show you here. When you see like down here, when you see a log scale and you see a number 2, what that actually means is the number that actually is 10 to the power of 2. So that's always going to be what it is. So what is 10 to the power of 2? What is it? It's 100, yeah? What is 10 to the power of 1? 10. So can you see that category has now become everything between 10 and 100. If I have this 10 to the negative 1, 10 to the negative 1 equals 0.1, yeah? And then so you're saying all the countries between negative 1 and 0 will be all those things. So that's what a log scale does. Can you see how here, when we draw the data here, this was the original data of, I think they collected body weights of animals in a zoo. So, of course, most of our animals aren't huge, big animals, but you had, say, I don't know if it was in a zoo or in general, but you had this big animal, maybe it was like a big whale or whatever, weighing a lot. And that's what drags. So when I look at it, it's not very good at spreading the data out. Can you see here, when we change it to a log scale, it spreads it out and makes it more easy to comment on, because it stretches those categories in a way that'll work. So if you look at it, that data, the original data, you would say is positive skewed with an outlier. The next one, we can say it's roughly symmetric. So how do we, let's have a look at this question here. Oh, sorry. And we go through, and I've gone through the answers there, so let's just have a look at it though. So it says a histogram shows the distribution of 27 animal species plotted on a log scale. What body weight in kilograms is represented by a number 4 in a log scale? So remember I said 4 means 10 to the power of 4. 10 to the power of 4 means 10,000 kilos. So if this animal, if we said it has a log number of 4, it must weigh 10,000 kilos. If I said it had a log score of 4.5, it would be somewhere between 10,000 and 100,000. Can you see that? So you don't ever get asked too much, but you need to know what it would be in between. All right, how many of these animals have a body weight more than 10,000? So you needed to realise a 4 means 10,000. So how much more? If you look at that, what's that? About, it says how many, so I can see it's about roughly 8%. So therefore, then 4. So therefore, 8% of the 27 animals, and we've found is equals 2.16. So there's about 2 animals whose body weight is more than 10,000. So then they ask, the weight of a cat is 3.3. Use your calculator to find the log scale. If you don't even need to use your calculator. If you know, 10 to the power of, what's 10 to the power of 0? Does anyone know? It's always 1. And if you've got 10 to the power of 1, it'll be 10. So if a cat is 3.3, wouldn't it be somewhere between that one, 0 and 1? Yeah? So if it says, did it ask what category? Oh no, it said to work it out. So anyway, you can, if you want to work that out, so I reckon it should have been somewhere between 0 and 1. And when you log 10 of 3.3, you get 0.52, so I was correct. And if you've got to go back the other way, if they tell you the log weight is 3.4, so I'm somewhere in between there, so I'm going to say I'm somewhere between 1,000 and 10,000, and you can see when they work that out, it ends up being 2,512. All right, so this will be a little bit different, so when you do the chapter, you might need to ask more questions if you need to. Here's how to log scale on your calculator. I won't go through that, you can have a look, but let's go through the exam questions because they're not that hard that you need to get your knickers in a knot over it. So a histogram below shows the population of 48 countries plotted on a log scale. Based on this histogram, the number of countries with a population size less than 100,000. What is 100,000 as a 10? 10 to the power of what? How many zeros are there? 10 to the power of 5 is 100,000. So they want less than that. So I'm looking at 5. So how many are less than that? If I go up there, that's 5, 6, that's 7 and 1. So how many are less than that? Is 8. So I've done that one. Here, the histogram below shows the distribution of log of the area in square kilometres of 17 islands. The median area of these islands is in between. Now, so let's go look. First, if the median, where will the median occur? If there's 17, occur if there's 17 countries. You can do 17 plus 1 divided by 2. The halfway mark would be the 9th spot. So if I've got 1 plus 3, what's that? 4 plus another 4, what would that be? 8. So does the 9th one occur in here? So the 9th is in here between log 3 and log 4. So that means 10 to the power of 3 to 10 to the power of 4. So 10 to the power of 3 is 1,000. 10 to the power of 4 is 10,000. So the answer will be D. I'm just going to do this last one. The histogram shows the distribution of number of billionaires per million people for 53 countries. Based on the histogram, the number of countries with one or more billionaire per million people. So you're trying to find the number 1 on the log scale. So what is a number 1 as a log? Remember I said 10 to the power of 0 equals a number 1. So you go up to 0 and they want the number of countries with 1 or more. So I want everything more than that. So to me that looks like about, is that a 9 plus a 1? So roughly 10. So I'll go E.